Today we are going to talk about Taylor series. Before that, let's look about power series about x equals to a. So you can see the equation sigma from n equals to 0 up to infinity, Cn bracket x minus a power of n. Let fx equals to the sigma n equals to 0 to infinity, Cn bracket x minus a power of n. You simplify it, you will get C naught plus C1 bracket x minus a plus C2 bracket x minus a square, and followed by Cn bracket x minus a power of n. Let's differentiate fx. So f prime x, you'll get C1 plus 2C2 bracket x minus a plus 3C3 bracket x minus a square, and followed by NCn bracket x minus a power of n minus 1. Let's differentiate it for the second time. You'll get 2C2 plus 2 times 3C3 bracket x minus a plus 3 times 4C4 bracket x minus a power of 2. Let's differentiate it again. So your f3 prime x, you'll get 2 times 3C3 plus 2 times 3 times 4C4 bracket x minus a, and so on. So from here we can get a general equation for f n prime x, which is equals to n factorial times Cn plus a sum of terms with x minus a as a factor. Okay, now let's substitute x equals to a into f prime x, f2 prime x, and so on. For first one, f prime a, we will only get C1, because for the rest, you can see there is a bracket of x minus a behind every constant, which means that when we substitute a into the f prime x, for the rest, we will get 0. So, for f2 prime a, we'll only get 2c2. For f3 prime a, we'll get 2 times 3c3. And we can generalize it as fn a, we'll get n factorial Cn. Why? Because C1 equals to 1 times C1 also equals to 1 factorial times C1. 2C2 equals to 1 times 2 times C2 also equals to 2 factorial times C2. 2 times 3C3 equals to 1 times 2 times 3 times C3 equals to 3 factorial times C3. Therefore, we can say that the term Cn equals to fn bracket a over n factorial. Okay, now let us look at the Taylor series representation equation. So your fx will equal to fa, the first term, plus f prime a bracket x minus a, your second term, plus f2 prime a over 2 factorial bracket x minus a square, your third term, and so on. You'll get an n term of fn bracket a over n factorial bracket x minus a power of n up to infinity. Okay, that's all. Okay, now let us move to the example part. For example 1, you can see that the question is when fx is equals to 1 over x and a equals to 2. So let us rewrite the fx into x to the power of negative 1 in order to differentiate it easily. So, after differentiate x to the power of negative 1, we'll get negative x power of negative 2. and we differentiate it again, we'll get 2x power of negative 3. Therefore, we can come up with a general conclusion, which is f and x will get negative 1 power of n times n factorial times x to the power of negative bracket n plus 1. Now let's substitute x equals to 2 into the fx, f prime x, and so on. When we substitute 2 into fx, when is f2, we'll only get 2 to the power of negative 1. When is f prime 2, we will get negative 1 over 2 squared. When is f2 prime 2, we'll get 2 factorial times 2 to the power of negative 3. Let's rewrite this term. For the f2 prime 2, we can write it as f2 prime 2 over 2 factorial equals to 2 power of negative 3. And we can come up with a general fn 2, which is equals to negative 1 bracket power of n times n factorial over 2 bracket n plus 1. For the f2 prime 2 and fn prime 2, we will rewrite it in the form like f2 prime 2 over 2 factorial, which is equals to 2 to the power of negative 3, and fn prime 2 over n factorial, which is equals to negative 1 power of n over 2 bracket n plus 1. Okay, now let us look about Taylor series. Our fx will equals to f2 plus f prime 2 bracket x minus 2 plus f2 prime 2 over 2 factorial bracket x minus 2 square, and so on, plus fn2 over n factorial bracket x minus 2 power of n, and so forth. Let us substitute the value we got just now into this equation. So we'll get 1 over 2 minus x minus 2 over 2 square plus x minus 2 bracket square over 2 cube minus so on plus negative 1 power of n bracket x minus 2 power of n over 2n plus 1 plus so forth. You can notice this is a geometric series with an initial value of half, which is your a, and your common ratio is negative bracket x minus 2 over 2. So, for s infinite, the formula of a over 1 minus r, after we substitute it, we'll get half over 1 plus bracket x minus 2 over 2. After we simplify, by multiply everything by 2, we'll get 1 over 2 plus bracket x minus 2. And we simplify further again, we'll left with 1 over x. For a geometric series to converge, the modulus of r should be less than 1. Thus, we can conclude that this series will converge absolutely when modulus x minus 2 over 2 is less than 1. Simplify that, we'll get modulus x minus 2 is less than 2. Or we can write it as the limit, the interval of 0, or the interval when x is in between 0 to 4. That's all.
Now we move on to the Maclaurin series, which is the Taylor series generated by a function at x equals to 0. So the function is sigma k equals to 0 to infinitive f k0 x to the power of k over k factorial, which is f0 plus f10 x plus f20 x squared over 2 factorial plus fn0 x to the power of n over n factorial. As you can see, the pattern of series is exactly same as the Taylor series except the x value. So the Maclaurin series generated by f is often just called the Taylor series of f. Let's look at the example now. Find the Taylor series generated by fx equals to cos x at x equals to 0. So we are finding the Maclaurin series here. First differentiation, we get negative sin x. Second differentiation, we get negative cos x. We cannot find the pattern yet, so continue to differentiate it in order to see the patterns. Third, we get sin x, and finally we get cos x back, which is the function x. So you can see the pattern now, right? Then we substitute x equals to 0 to the function. We get 1, 0, negative 1, 0, and then 1 again. If you cannot find the general form of this series, you can just expand it first. So the fx equals to 1 plus 0x minus x squared over 2 factorial plus 0x cubed plus x to the power of 4 over 4 factorial. Now can you see the pattern? All the odd power of x cancels off due to the value of function when x equals to 0. So we can find the general form of this function as negative 1 to the power of n x to the power of 2n over 2n factorial. Don't worry if you cannot find the general form of this function. We can just leave it as 1 minus x squared over 2 factorial plus x to the power of 4 over 4 factorial minus x to the power of 6 over 6 factorial, and so on. Thank you very much for watching. I hope our video helped you for this chapter by now.